Hi, welcome to a tutorial on tips and tricks for pipes and cisterns from careerright.com. Pipes and cisterns is similar to time and work and is one of the favorite category of questions in placement tests, job interviews and all competitive exams. Since every exam generally has 1 to 2 sums of pipes, it is important to learn how to quickly solve these sums. For practice, you can go to careerright.com. So now, let's begin. Just like time and work, even pipes and cisterns has a very small tip which will help you solve all the sums related to pipes and cisterns, and that is nothing but just invert. Okay, now we have seen the inverting tip in time and work. We'll see it again over here, but before going to the tip, let's understand what exactly we are meaning by invert. Let us assume that this is a tank. Okay, now this is the capacity of the tank over here. Okay, now the tank is completely filled. Let us assume that the tank gets completely filled in 2 hours. Okay, so in 1 hour, how much would the tank get filled? Simply half of the tank, right? So if in 2 hours a complete tank gets filled, then in 1 hour, in just 1 hour, how much tank would get filled? Half of the tank. That means 1 by 2. What did we do over here? We simply put this 2 down. We simply inverted it. Take another example on the right hand side. Say this is a tank, it is completely filled. Okay, now this tank gets completely filled in say 4 hours, right? In 4 hours. So in 1 hour, right, in 1 hour, how much of the tank gets filled? 4 hours, 100%. Then 2 hours, that is half of the time, 50%. Again 1 hour, 50% of that is 25%, right? So 25% of the tank gets filled in 1 hour. What is 25%? 25% is nothing but 1/4, right? What did we do? We took this 4 and we put it down over here. So we got 1/4. We just inverted. That is the same over here. When we have n, we just invert it and get 1 by n. When we have 1 by n, we invert it to get n, right? This is nothing but the rule of invert. If you remember this rule, you will be able to solve all the sums related to time and work, related to pipes, as well as some sums related to wages and work, etc. Okay, so now over here, let's take an example to understand what do you mean by invert. Let us say that a pipe fills a tank in 8 hours. Okay, entire tank is filled in 8 hours. Then in 1 hour, okay, in 1 hour, how much amount of tank is filled? 1 by 8. We take this 8, we put it over here, we just invert. So 1 by 8 amount of the tank is filled in just 1 hour. If they have given that 1 by 8 amount of tank is filled in 1 hour, then the entire tank is filled in how much time? Simply invert and we get 8 hours. So here we see the time which is given hours gets converted into work done. That is the amount of tank filled while inversion, and again while inversion vice versa. When we go from amount of tank to hours, again the work done gets converted to time. So time gets converted to work and work gets converted to time when we invert. Okay, so it is not difficult, it is very easy. Whenever they have given number of hours, you can invert and get the amount of tank filled in just 1 hour. Very small concept, another one which you should remember. It is very easy, you have learnt it from childhood. Okay, whenever say a tap is filling a tank, that means what is happening? Water is getting added, right? So whenever we fill a tank, we generally add. Now whenever there is a tap, okay, for example we have a vessel and it has a tap for water. When we open the tap, the vessel will get empty. When the vessel is getting empty, that means water is getting removed. So water is getting removed means subtraction. So whenever we are removing water, we subtract. Whenever we are filling water, we add. These small things are these are the only small things necessary to solve all the sums related to pipes and cisterns. Let's see how to use them while solving the sums. Question number 1. Two pipes M and N can fill a tank in 22 hours and 33 hours respectively. In how much time will the tank be full if both the pipes are opened simultaneously? Now this is just like time and work sum. Okay, if you have not seen the video for time and work, you can take a look over there, so you'll get a better understanding how to solve these sums. But I'll teach you over here also how to handle sums related to pipes and cisterns. Okay, now what did we learn? We just need to invert, right? Now there's another thing. Say what we did over there was that if the tank gets filled in 22 hours, then what we found out in 1 hour, how much of the tank gets filled, right? So we need to find out the work done in 1 hour. So every time what we just need to remember two things, invert and find the 1 hour work done. Now over here there are two pipes. First is pipe M. It fills the entire tank in 22 hours. So in 1 hour, how much of the tank gets filled by pipe M? Simply invert. So 1 by 22. So 1 by 22 amount of tank gets filled by pipe M. Now there is pipe N. It fills the entire tank in 33 hours, right? So in 1 hour, how much tank gets filled by pipe N? Simply invert. That is 1 by 33 amount of tank gets filled. So this is the 1 hour filling by pipe M and pipe N respectively. Now what they say, that if both pipes are opened simultaneously, so M is opened and plus N is opened, right? Both are opened. Then how much of the work would be done in 1 hour? How much? It would simply be work done by pipe M in 1 hour is 1 by 22 plus N is also open, so work done by N in 1 hour, right? So what is the LCM? We'll have 22 into 33. This is 33 plus 22. We'll have 55 upon 22 into 33. 11 5s are 11 3s are. So that would be 5 upon 66. This is the amount of work done by M and N together in just 1 hour. This is not the amount of hours taken. This is not the total amount of work done. This is just the work done by M and N in 1 hour. So now how much if in 1 hour M and N do 5 upon 66 amount of work or fill 5 upon 66 amount of tank, then the entire tank will be filled in how many hours? Simply invert, right? What do we get on inversion? 66 upon 5. So in 66 upon 5 hours, the entire tank gets filled by M and N both opened simultaneously, right? See how easy it was. You just find the 1 hour work done. You find the total work in 1 hour by both the pipes and you just invert it. Okay. Moving to question number 2. Pipe P can fill a tank in 38 hours. Pipe Q alone can fill it in 19 hours. Pipe R can empty the full tank in 133 hours. If all the pipes are opened together, how much time will be needed to make the tank full? Again, this is very easy. It is just like it is similar to the previous sum. Let's see how to solve this. We know what did we learn over here for pipes and cisterns. We just need to invert and we need to find 1 hour work. This is similar to what? Time and work. Okay. So over here, what have they given? There is pipe P. It can fill the entire tank in 38 hours. So in 1 hour, how much of the tank would be filled by pipe P? 1 by 38, right? Why? We just invert. Now pipe Q, it fills the entire tank in 19 hours, right? So in 1 hour, how much tank gets filled by pipe Q? Just invert. 1 by 19 amount of tank gets filled. Then there is pipe R. Now pipe R empties the full tank in 133 hours. Okay. So in 1 hour, how much of the tank gets emptied by pipe R? Just invert 1 upon 33, right? In the previous sum, we had two pipes, M and N. And what we did when we opened both of them, we just added them, right? Now over here, say we open all the three pipes. What do we get? We have pipe P, we also open pipe Q, and we also open pipe R. But should this be minus or plus? This should be minus. Why? Because pipe R is emptying the tank. We have learned whenever we are filling the tank, we will take plus. Whenever we are removing water, we will take minus. Okay. So this is removing water. Pipe R is removing water. So what we will have over here? We will have P plus Q minus R. All the tanks, all the pipes are opened simultaneously. So in 1 hour, Okay, in 1 hour, what would be the work done by pipe P? 1 by 38. In 1 hour, what would be the work done by pipe Q? 1 by 19. In 1 hour, how much of that water would be removed by pipe R, or how much work done would be removed by or done by pipe R? Minus 1 by 133. On solving, let's see what do we get. We have 19, if we take 133 as LCM, because 19 into 7 is 133. 7 plus 7, 63, yeah, 133. So 38, okay, for 133 we'll have 1 over here. For 19, 7s are 133, okay, and 38, 38 is twice of 19. So this should be half, 3.5. Okay, so what we will get over here? We will have P plus Q minus R would be 7 minus 1 is 6, 9.5 upon 133. Now 9.5 is what? Half of 19, right? So if 19 sevens are 133, then 9.5 14s are 133, right? So what we get? 1 by 14. This is not the number of hours, this is nothing but amount of work done by pipe P, Q and R together in just 1 hour. Okay, in 1 hour pipe P, Q and R do 1 by 14 amount of work, that is they fill 1 by 14 amount of tank. So the entire tank would be filled in how much hours? Simply invert, that would be 14 hours, right? Because 1 by 14 is nothing but 14 by 1, that is nothing but 14 hours. So when pipe P, Q and R are opened together, 14 hours are needed to make the tank full. Moving to question number 3. A tap can fill a tub in 24 hours. Due to a leak at the bottom of the tub, the tap fills the tub in 36 hours. If the tub is full, how much time will the leak take to empty it? Again, this might look like a little bit difficult or not like the taps and pipes what we have seen up till now. So, but this is very easy. It is similar to the sums what we solved. Let's understand what they have given. There is a tank, they say, okay, and what they are saying is that there is a small leak over here. So water is falling from here. Now there is also a tap over here, right? This is a tap. Now this tap, it is filling the tub in 24 hours normally. But due to this leak which is there, the tub gets filled in 36 hours, right? Due to this leak. Now what we have to find out is that if the tub is full, how much time, and the tap is closed. Now the tub is full and tap is closed. Then how much time will the leak take to empty the entire tub, right? Now what we'll do over here is, what we learnt over here, we'll have invert and we'll find the 1 hour work. Okay. So here what they are saying, say there is a tap. Now tap can fill the entire tub in 24 hours normally, right? So in 1 hour, how much of the tub gets filled? 1 by 24. Why? We just invert. This is the 1 hour work done for the tap. Now this tub is leaking. This is nothing but like the tap R which we have seen in the previous sum, where the tap R is emptying the we are emptying the tank, right? So this is nothing but like tap R. So what we did for tap R, we simply subtracted it, right? So whatever is there, so we opened our normal tap, right? Then we subtracted the leak, right? And then we get the total amount of work done in 1 hour. Is that right? Yesterday, in the previous sum, what we saw was that we had pipe P which is filling, pipe Q which is filling, and pipe R which is emptying. So we had P plus Q and minus R. So over here we just have tap P, Q is not there, and we have the leak which is tap R. So we will have P minus R. Then what we got? That is both of them are open. So in 1 hour, how much work is done totally? Same way over here. In 1 hour, normally the tap does how much work? 1 by 24. How much work is done by the leak? We do not know in 1 hour, right? What is the total work done in 1 hour? Let's see. Now they have given is that due to the leak, that means the leak is on as well as the tap is on. The entire tub gets filled in how much? 36 hours. Is that right? So in 1 hour, how much of the tub gets filled? 1 by 36, right? Because we just invert. So when the leak is going on, when the leak is on, when the tap is on, when both the things are on, total tank or the total tub gets filled in 36 hours. So in 1 hour, only 1 by 36 gets filled. So that is nothing but the total work done in 1 hour, right? So how much would be the leak be? 1 by 24 minus 1 by 36 would be the work done by leak in 1 hour. That is nothing but the LCM 36. 72 is the LCM. 3 minus 2 equal to 1 by 72. This is the amount of work done by the leak in 1 hour. If in 1 hour the leak does 1 by 72 amount of work, then the leak will empty the entire tank in how many hours? Simply invert, that is 72 hours. See how easy it was. You can look at it this way, that normally the tank gets filled in 24 hours, but due to the leak, that is the tap is open as well as the leak is open, okay, due to the leak it gets filled in 36 hours. So this is the work done by just like let's take example of P, Q and R. This is the work done by tap P and leak is nothing but tap R. So due to the leak, when 36 hours it takes for the tub to get filled, this is nothing but the work done by P and R together, and we have to find out how much is the work done by R. What do we do? P minus R and work done by P and R together. So we simply subtract. This is the same thing what we did over here. Work done by tap plus work done by leak. Since work done by leak is nothing but emptying the tank, so we took minus. That is nothing but equal to the total. This is minus. Okay. That is nothing but the work done by the tap and the leak together in 1 hour. We found out we got 72 hours. See, very easy. This is similar to the previous sum only. There is nothing to it. Only the words are a bit different. Moving on. Question number 4. Two pipes M and N can fill a tank in 22.5 and 15 minutes respectively. If both the pipes are opened simultaneously, after how much time should N be closed so that the tank is full in 18 minutes? Now this sum is very easy actually. This is similar to the sum where like the time and work sum where the Sita leaves in between. Okay, so I have explained it over there, but I'll explain it again over here, how to solve these kind of sums where something is closed in between or something gets opened in between. Okay, there's this timeline and all that stuff. They are very easy, and it's easier to solve them, much easier to solve them if you have a line diagram or draw a line diagram. What is a line diagram? It is nothing but just draw a line. Okay, now over here the tank is empty and over here the tank is full, that is the zero work done, entire work done. Okay, so M and N, pipes M and N are opened over here. They start filling the tank. After some time, say at this point, N is closed, right? And what happens now? Only M is on. So over here M and N both were on, then N was closed. Now only M is on, and what happens because of this? Because of closing of N, the entire tank should get filled in 18 minutes. So it is not 18 minutes from here, it is 18 minutes from empty. That is, from empty tank to the full tank, the entire tank should get filled in 18 minutes. So we have to close N at such a point. Okay, now do we know at what point or after how many minutes we have to close pipe N? No, so let us assume that pipe N should be closed after X minutes. That means pipe M and N both are working for X minutes, then after that N is closed and then only M is working. Okay, now from this diagram let's see how to solve the sum. What have we learnt in pipes and cisterns at the start? Just invert and find the 1 hour work done. But 1 hour work done, do we have hours over here? No, we have minutes. So instead of hour we will have 1 minute work done. That is the amount of work done by the pipe or a tap in 1 minute. What have they given? Pipe N, okay, fills the tank in 15 minutes, correct? So in 1 minute how much tank would be filled by pipe N? 1 by 15. Why? We just invert. M fills the entire tank in 22.5 minutes, okay, when it is on alone. So in 1 minute how much of the tank is filled by pipe M? 1 by 22.5, because we just invert. So in 1 minute pipe M fills 1 upon 22.5 amount of tank, right? Now over here we see that M and N in this diagram, line diagram, we see that M and N are on, then N gets closed, only M is on. That means M is on for the entire time. So M is on from empty to full. Okay, pipe M is on continuously from start to end. That means M is on for 18 minutes. So if in 1 minute work done by m is 22.5, 1 upon 22.5, then in 18 minutes work done would be how much? Simply work done in 1 minute multiplied by total number of minutes, that is 18. So we'll get 18 upon 22.5. This is the amount of work done by m totally, entirely from start to end. Okay. So if now, since we are filling a tank, we cannot quantify it. So work done is generally taken as 1. Out of that, 18 upon 22.5 amount of work is already done by m. So how much work is remaining? 22.5 minus 18 is 4.5 upon 22.5. Who will do this work? Only n. Why only n? Because here we have already considered the work done by m, okay, entirely. Only n is remaining, that is only pipe n is remaining. So this is the work done by pipe n alone, right? Now, for how much time is pipe n on? Pipe n is on for x minutes, we have assumed, right? Correct? So in 1 minute, pipe n does this much amount of work. This is in 1 minute. So in x minutes, how much amount of work would be done? 1 minute work multiplied by total amount of minutes, that is x upon 15 amount of work is done by pipe n in just x minutes, right? So pipe n does x upon 15 amount of work in x minutes, that is nothing but this is the work, that is 4.5 upon 22.5. Why? Because we already know total amount of work done by n is this 4.5 upon 22.5, and we have also found out over here that n is on for x minutes, and in x minutes n does x upon 15 amount of work. So these two works should be equal. So what we will write over here? X upon 15 equal to 4.5 divided by 22.5, right? So what we will get over here? This is 5s are, this is 3s are. So x equal to 3, that means 3 minutes. That means n has to be closed after 3 minutes so that the entire tank gets filled up in just 18 minutes. Right? See how easy it was. Just invert, find the 1 minute work and draw the line diagram. Moving on. Question number 5. Pipe A can fill a tank 5 times faster than pipe B and takes 32 minutes less than pipe B to fill the tank. If both the pipes are opened together, then in how much time will the tank would be full? Now a similar kind of sum we have seen in time and work. Again, let's see over here how to solve these kinds of sums. These are very easy, there is nothing to it, okay, just common sense is needed, right? Now what have they given? They have given that pipe A can fill a tank 5 times faster than pipe B. That means A is faster than B. What does that mean? B is slower than A, right? B is slower than A. Now A is 5 times faster than B, 5 times. So B is also, what does that mean? B is 5 times slower than A. If a machine is slow, okay, if a machine is slow, time taken will be more. So if B is 5 times slower than A, B will take 5 times more time than A. So that means if A is doing a work in 1 minute, B will take 5 times more time. That is, B will do it in 1 minute into 5 minutes. Right? So if A is doing a work in T minutes, right? T minutes, how much time will B take? B will take 5 T minutes, right? Because B is slower, 5 times slower. So time taken by B will be 5 times more, right? And also they have given that pipe B takes 32 minutes less, pipe A takes 32 minutes less than pipe B. So pipe B takes 32 minutes more than pipe A. So pipe B is 5T. Out of that, when we remove 32 minutes, we'll get the time for pipe A, right? So because pipe A takes 32 minutes less than pipe B. So what this would be? This would be simply 4T equal to 32, T equal to 8 minutes. That means A takes 8 minutes to fill the tank. So how much will B take? B, this is nothing but A. So B will take 5T, that is 5 into 8 is 40 minutes, right? Now let us see if both are opened together, in how much time the tank would be full. What have we learned? Invert and find the 1 hour work done or 1 minute work done, right? So 1 hour, we don't have hours over here, we have minutes. So 1 minute work done. What do we have? Pipe A fills the entire tank in 8 minutes. So in 1 minute, how much tank is filled? Simply invert 1 by 8. There is pipe B. Okay, fills the entire tank in 40 minutes, 5 times more time, right? So in 1 minute, how much tank is filled? 1 by 40. This is I, right? So if both the pipes are opened, A is opened plus B is opened, then in 1 minute, how much of the tank is filled? 1 by 8 by A and 1 by 40 is filled by B. LCM is 40, we will have 5 plus 1 equal to 6 by 40, that is 3 by 20. Okay, this is not the number of minutes, this is nothing but A and B when opened together complete 3 by 20 amount of work in 1 minute. So when A and B are simultaneously opened, then 3 by 20 amount of tank is filled by A and B in just 1 minute. So if in 1 minute 3 by 20 amount of work is done, then in how much time will the total work be done? Simply invert. What do we get? 20 upon 3 minutes. So A and B when opened simultaneously completely fill the tank in just 20 minutes. Moving on to question number 6. A tank has 3 taps P, Q and R. Taps P and Q can fill the tank in 1.5 and 2 hours respectively. Tap R can empty the completely filled tank in just half hour. Tap P is opened at 8 am, tap Q is opened at 9 am and tap R is opened at 10 am. At what exact time will the tank be empty? Now this might look complicated, but it is not. It is pretty easy. Just we need to do what we did earlier. Okay, what did we learn? Just invert and take the 1 hour work done. This is similar to the time and work stuff, right? Now let's understand the sum and solve it. Now let's draw a clock to understand it better. This is 9, this is 8 am, this is 10 am. They say that pipe P is tap P is opened at 8 am, Q at 9, R at 10, and they are asking at what exact time will the tank be empty. We do not know at what time the tank will be empty, so let us assume that when P is on after T hours, after T hours, let the tank get empty. Okay, over here at this point after T hours, when P is on at 8 am, when we start P at 8 am, after T hours the tank gets empty at this point, right? So P is on for how many hours? T hours. Q is on for how many hours? T minus 1 hours. Why? Because Q was started at 9 am, that is 1 hour late, and similarly R was started 2 hours late, so T minus 2 hours. So R will be open for T minus 2 hours, this much time. Okay, now what have we learned? Invert and 1 hour work done. P can fill the entire tank alone in 1.5 hours. So in 1 hour amount of work done by P or tank filled by P is 1 upon 1.5. Why? We just invert. Let's not keep it in decimal. 1.5 is nothing but 3 by 2. That would be 2 upon 3 is the amount of work done by P in 1 hour. Same way Q. 2 hours work done in 1 hour by Q or amount of tank filled is 1 by 2 because we invert, right? This is the work done by Q in 1 hour. R empties the entire tank in half an hour. So work done in 1 hour is 1 upon 1 by 2, that is tank emptied in 1 hour is 1 upon 1 by 2. Why? Because we just invert, that is 2 work done by R in 1 hour. Okay, now what they have given over here? There is a tank which is empty at first, then taps are on, so some water gets filled, then after T hours again the tank gets empty. So initial it is empty, finally it is empty, both the states, first and the last state is empty, so the total work done is simply 0. There is no change, so the total work done is 0. So total work done by P plus total work done by Q plus total work done by R is 0. This is not the 1 hour work, this is the entire total work done by P, Q and R is 0, right? Now what have we learnt at the start? When we fill the tank, we take plus. When we remove water, okay, we take minus. Over here, P and Q are filling the tank, so we took plus plus. R is removing water, so we have to have over here minus. So what do we get? Total work of P plus total work of Q minus total work of R is 0. How to find total work of P, Q and R? Very, very easy. Take a look over here. Total work of P, work done in 1 hour is 2 by 3. Amount of time for which P is on T hours. This is the total work of P plus total work of Q. over here, total work of Q or work done by Q in 1 hour, 1 by 2 multiplied by amount of time for which Q was on, T minus 1, minus work done by R in 1 hour is 2, for a time for which R was on, T minus 2 hours equal to 0. So what do we get? 3 and 2, let's take the LCM, it is 6. So we will have over here 4T, okay, let's solve. 4T plus 3T minus 3 minus 6 2s are 12. So we will have 12T plus 6 2s are 12, 12 2s are 24 plus 24 equal to 0. That would be nothing but 4T plus 3T, 7T minus, this is minus 5T equal to minus 21. Therefore, T would be equal to 21 by 5, that is 4.2 hours. 4.2 hours is nothing but what? 4 hours plus 0.2 hours. Let's find what is 0.2 hours. 1 hour is 60 minutes. So 0.2 hours is how much? It is simply 0.2 into 60, that is 12 minutes, right? So the work done or the tank would be emptied after 4 hours 12 minutes after P was on. P was started at 8 am, right? P was started at 8 am, add 4 hours 12 minutes, so the exact time would be 12 pm 12 minutes, right? Because since it is am, that is in the morning that P was started, 12 it would be afternoon, that is 12 pm and 12 minutes. So the time would be 12 when the entire tank would be empty. See how easy it was to solve, just basic formula is needed and nothing else. Moving to next question. Question number 7. A cistern can be filled in 6 hours by taps P and Q. If tap R also joins them, then cistern is filled in 5 hours. If tap P can fill the cistern at twice the rate of tap Q, in what time tap Q and R fill the cistern? Again, pretty easy. There is nothing much to it. We have to use the basic formulas, that is inversion, and find the 1 hour work done. Let us see. Now, do we know in how many hours does P fill the tank? No, we do not know. For Q, we don't know. For R, we don't know. So let us assume what we do. P, when working alone, takes P hours to fill the entire cistern. So in 1 hour, how much amount of cistern will be filled by P? Simply invert, that is 1 by P. Correct? Same way for Q, let Q take Q hours to fill the entire cistern. So in 1 hour, amount of cistern filled is 1 by Q. Same way R, take R hours. Let us assume it takes R hours. So inversion, in 1 hour it fills 1 by R amount of cistern, right? They have given that a cistern can be filled in 6 hours by taps P and Q. So if P is on and Q is on, how much amount of work is done in 1 hour? That is work done by P in 1 hour plus work done by Q in 1 hour, right? This is nothing but 1 by P plus 1 by Q. Now, they have given that P and Q together fill the entire tank in 6 hours. So in 1 hour, P and Q together fill how much amount of tank? Simply invert, that is 1 by 6. But we already know that when P and Q are working in 1 hour, they do 1 by P plus 1 by Q amount of work. So 1 by P plus 1 by Q is nothing but 1 by 6, right? So this is our first equation. Same way, they have given P, Q and R, they fill the entire tank in 5 hours. So in 1 hour, P, Q and R fill 1/5 of the tank, right? Because we simply invert. Now over here, when P is on, when Q is on and when R is on, work done in 1 hour is what? Work done by P in 1 hour plus work done by Q in 1 hour plus work done by R in 1 hour, right? But this is nothing but 1 by 5, right? This is nothing but this 1 by 5, because we already know that if in 5 hours the tank gets filled, in 1 hour 1/5 gets filled. So 1 by 5 is nothing but 1 by P plus 1 by Q plus 1 by R. This is the second equation. Put value of equation 1 into 2. What will we get? We will get 1 by 6 plus 1 by R equal to 1 by 5. Let's solve this. We get 1 by R equal to 1 by 5 minus 1 by 6. Therefore, 1 by R is 1 by 30. So this is the amount of work done by R in just 1 hour. Correct? Right? Now, let us find out the work done by P and Q. Let's see. What do we need actually over here? Time taken by Q and R to fill the cistern. So we don't need P, actually we need Q and R. So let's see how to solve the remaining of the sum. What have they given? P can fill the cistern at the rate twice of tap Q, right? So if in 1 hour, if we take 1 hour, P will do twice the work of Q, because P is 2 times faster than Q. Rate of flow of water from P is 2 times the rate of flow of water from Q. That means in 1 hour, amount of work done by P will be 2 times the amount of work done by Q. What is the amount of work done by P in 1 hour? 1 by P. That is 2 times the work done by Q in 1 hour. Correct? So 1 by P is nothing but 2 upon 1 by Q. We already know from equation 1, 1 by P plus 1 by Q would be equal to 1 by 6. Substitute the value, what do we get? 2 upon Q is nothing but 1 upon Q plus 1 upon Q is equal to 1 by 6. So what is this? What do we get? 3 upon Q equal to 1 by 6. So Q would be 1 upon Q would be 1 upon 18. That means work done by Q in 1 hour, right, is nothing but 1 by 18. So work done by Q in 1 hour plus work done by R in 1 hour. What is the answer for this? 1 by 18 plus 1 by 30. That would be how much? 18 into 30. We will have 30 plus 18, that is 48, right? So 6 8s are 48, 6 5s are 2 9s are 2 4s are. So that would be nothing but 4 upon 45. So in 1 hour, Q and R do 4 upon 45 amount of work in 1 hour. So entire work would be done by them in how many hours? Simply invert, that would be 45 upon 4 hours, right? So this is nothing but the time taken by Q and R to fill the cistern. 45 by 4 hours. This is the answer. Moving on. Question number 8. A cistern is filled by pipe A and pipe B together in 2.4 hours. Pipe A alone can fill the cistern at the rate of 100 liters per hour. Pipe B alone can fill the cistern in 4 hours. What is the capacity of the cistern? So this is a little bit different sum, but we have to use the same approach, and hence we can say that this is very easy. What is the approach? Invert and find the 1 hour work done. Now do we know that how much time does pipe A alone take to fill the tank? No. So let us assume that there is pipe A and A takes A hours to fill the entire cistern. Okay. So in 1 hour, how much cistern is filled by A? Simply invert, that is 1 by A. For B, B takes 4 hours to fill the entire cistern. So in 1 hour, amount of work done is 1 by 4, or B fills 1/4 of the cistern. A is on, B is on, right? So in 1 hour, work done by A will be 1 by A plus work done by B will be 1 by 4. So when A and B are on, in 1 hour, total work done is 1 by A plus 1 by 4. Now what have they given is that pipe A and B, when they are opened simultaneously, they fill the entire cistern in 2.4 hours. Is that right? Okay. So in 1 hour, how much amount of cistern is filled by pipe A and B? 1 upon 2.4, right? So it is 1 upon 2.4. But we already know that when A and B is on, okay, the amount of tank filled is nothing but A plus B. In 1 hour, amount of tank filled is A plus B. So that is nothing but this, right? So these two are equal. So we have 1 by A plus 1 by 4 equal to 1 by 2.4. What is the value of 1 by A? That would be 1 upon 2.4 minus 1 by 4. We get over here 1 by 6. That means this is the work done by A alone in 1 hour. So in 1 hour, if A does 1/6 amount of work or fills 1/6 amount of tank, then the entire tank is filled in just invert, that is 6 hours, right? So that means if we keep pipe A on, okay, if we keep pipe A on for 6 hours, cistern which is there, not tank, cistern which is there, it gets completely full, right? Now A is giving out water at the rate of 100 liters, okay, liters per hour. So in 6 hours, how much amount of water will be given by A? 6 into 100, that would be 600 liters, right? So A gives out 600 liters in 6 hours, and we know that when A is on for 6 hours, cistern gets full. That means capacity of the cistern is 600 liters. See how easily you got the answer. We just need the basic formula and we need to apply it. Moving to question number 9. Pipe R can empty a full tank in 30 hours. But two pipes P and Q can fill a tank in 15 hours and 10 hours respectively. Ram unknowingly opened all three taps. After 2 hours, Sham realized it and closed pipe R. Due to this mistake, how much time more would it take to fill the tank? Again, this looks very complicated, but it is not. It is very easy. Just go step by step. Whatever we have learned, that is inversion and 1 hour work done, and we can very easily solve the sum. Now what they say is that normally P and Q, which fills the tank, they are filling the tank, right? But Ram by mistake opened all the three tanks, all the three pipes, because of which what happens is that it takes more time to fill the tank, because slowly water is also going out because of pipe R. So how much more time is needed, that they want. So again, this is easy. We have understood the sum. Let's see how to solve it. Now P, like one, we have to find 1 hour work, inversion, right? P, how much time does it take? 15 hours to fill the tank alone. So in 1 hour it does 1 by 15 amount of work. Q takes 10 hours. So in 1 hour does 1 by 10 amount of work. R empties the tank in 30 hours. So in 1 hour 1 by 30 amount of tank is emptied by R. So we have found out. Now normally what happens? Normally in normal conditions, okay, P and Q are opened, because if we want to fill a tank, we will just open P and Q and they will fill the tank. Why will we open pipe R which empties the tank? So normally we will just open P and Q, okay. So in 1 hour, how much work is done by P and Q? It would be 1 hour work of P plus 1 hour work of Q. That is nothing but 5 upon 30. How do we get 5 upon 30? I'll just explain. LCM is 30. So 15 2s are 10 3s are. So we got 5 upon 30. This is the amount of work done by P and Q when both are opened. Normally, okay. Normally when just P and Q are opened. That means when P and Q are opened in 1 hour, they do 5 upon 30 amount of work or fill 5 upon 30 amount of tank. So the entire tank will be filled by P and Q in how much time? Simply invert, that is 30 upon 5, that is equal to 6 hours. So normally when P and Q are on, they will fill the entire tank in just 6 hours. Now let us see our abnormal condition where Ram makes a mistake, okay. What mistake has been made by Ram? Okay, what he did was that he opened P, Q and R simultaneously. So he opened P, he opened Q and he opened R. Okay, now over here P and Q fill the tank, R is emptying the tank, so we cannot have plus over here, we should have minus. So what do we get? P plus Q minus R. Okay, what is the in 1 hour? In there are 3 taps, okay, or there are 3 pipes and these 3 pipes are opened. So work done by these 3 pipes in 1 hour is nothing but work done by P in 1 hour, 1 by 15, work done by Q in 1 hour and work done by R in 1 hour. That would be LCM is 30. Here we will have 15 2s are plus 10 3s are minus 1, 5 minus 1 is 4, that is 4 upon 30. This is the amount of work done by P, Q and R in just 1 hour. Now Ram opened the 3 taps and after 2 hours Sham closed pipe R. That means for 2 hours P, Q and R were open. For 2 hours P, Q and R were open. So how much of the tank gets filled by this in 2 hours? How much the tank gets filled? Simply in 1 hour 4 by 30 amount of tank gets filled. So in 2 hours just double, that is 8 by 30 amount of tank gets filled because of P, Q and R in 2 hours. Now how much of the tank is remaining? Simply it is 1 minus 8 by 30, that is 22 by 30. This much amount of tank is remaining, right? Now who fills this much amount of tank? R has been already closed, so only P and Q will fill this, right? Only P and Q will be filled because will fill this much amount of tank because Sham has realized the mistake and closed R. So only P and Q is on and they will fill 22 by 30 amount of tank. Now what do we know? P and Q in 1 hour, how much amount do they fill? 5 upon 30, right? Why? We have found it over here. right? We have found it over here that P and Q, when they are on normally, in 1 hour they fill 5/30 amount of tank. So in how much time will they fill 22 upon 30 amount of tank? Simply cross multiply. What do we get over here? We will get 22 upon 30 multiplied by 1 would be equal to 5 upon 30 multiplied by question mark. 30 gets cancelled. So we have question mark equal to 22 upon 5. That is nothing but 4.4 hours, right? So 22 by 30 amount of tank is filled in 4.4 hours. 8 by 30 amount of tank is filled in 2 hours. So total time taken in the abnormal cases 2 hours plus 4.4 hours equal to 6.4 hours. So normally we take 6 hours. Now we are taking 6.4 hours because tap R was opened by mistake by Ram. How much extra time? 6.4 minus 6 hours, that is 0.4 hours, right? Now 1 hour is how much? 60 minutes. 0.4 hour is how much? 0.4 into 60, that would be simply 24 minutes. So 24 minutes more are needed when pipe R is accidentally opened for 2 hours. See how easy the sums were. Even if they were a bit tricky, we could easily solve it using inversion and the 1 hour rule. So just remember this tip of inversion and 1 hour rule and you will be able to solve any sum related to time and work as well as pipes and cisterns. So if you like this video, please give it a like and share it with others. You can also leave your comments and suggestions below. Also, do let us know if you have some topic in mind and we will develop a video on it for you. Don't forget to subscribe to our channel so as to stay updated for more such tutorials and videos by us.